the following part of the extreme value theorem. Talking about the extreme, right? Extreme, change to the yellow. Um, this time local. Local, that means no left and no right end. Okay. Local extreme. Extreme mean either max or min. This theorem said if f has local max, local min, or in the graphical way where the graph turns in between point A and point B at x equals c, and you can find the derivative f prime at c exists, that means you can find the derivative. Then the derivative at point c equals 0, which is true, right? Where the graph turn, the slope at the turning point, the slope of the tangent line is 0, right there. Okay. And then for the case that the the graph that has the local for the point A here, local minimum at C. For the graph here, you have the graph that is smooth all the way until the point C. It has the hole in there. The graph is not continuous, but you can find the function value. That function value, yes, is a local min, but the derivative doesn't exist because the graph is not continuous. Okay, not continuous. So kind of it doesn't follow this theorem. From the graph, you can tell one number, but you cannot tell the other condition of of the local extreme point theorem. Another case here, from the graph, you can tell the local max by looking at the behavior of the graph. That's the maximum in the small neighborhood there. Okay, that's the local max. But the derivative doesn't exist. So kind of if you can look at the graph, you can determine the local max or local min. It doesn't mean the derivative always exists. But if the derivative always exists, if you know already that the derivative can be found, then the derivative gonna be 0 at that local max or local min. Okay, too much explanation. Basically, look at the graph. If you have the smooth turn, the derivative can be found and the derivative is 0. That's a short version of this theorem. Okay. Another one, an interior, talking about interior point x equals c of the domain, that means within the interval provided. If you can find the derivative and you know it's 0, or you can find the derivative and it's undefined, like these two cases, as a whole or a sharp turn. So either way, for the derivative that either 0 or cannot be found, that point C is called critical point. It's called critical point. So the critical point gives you the possible local max or local min. Okay, and we're gonna wrap up in a little bit for the certain name as a critical point. Let me write in the shorter version of this. So the recap of this slide, um, you start with the f of x. Okay, f of x is given. You find f prime. You find f prime, and then gonna be two cases. F prime at x equals 0, or f prime at x is undefined or doesn't exist. But usually we use undefined for the function, doesn't exist for the limit. One of these two cases, the x is called critical value. Critical value. Or the critical point, I should use the term critical point because the value for the y value. So critical point, the critical point could be local max, local min, or not local max, local min. So it doesn't guarantee. Okay. But it's still called critical point. So the first use of the derivative is to find the critical point for this section. And for this example, we have the information for the function f on the interval. This is a closed interval. This is closed. Okay, interval from -5 to -2. Information that we have here, f prime equals 0. F prime 0 means the m of the tangent equals 0. Okay, that we know from earlier chapter. At the point -4 and -3, if the slope 0, so it could be either local max or local min because the slope is 0. Local max or local min. Okay, at -4 and -3, just analyze information provided. And the next one, f has the an absolute maximum at x equals -2. So then that means f at -2 is greater than or equal to all function value within the interval -5, -2 by the definition of absolute max, and similar to f at -5 as the absolute minimum value less than or equal to overall function value. And f has a local, the term local minimum at x equals -3. It goes back to the first condition there. At -3 slope 0, and also the local minimum at x equals -3. It's kind of the relationship of the first condition and second condition. Now we're gonna sketch the graph. The graph, you can have like more than one option for the graph. So whatever that it come to your mind first, just go with that. It doesn't give you the function values for any point -4, -3, -2, or -5. Just give you the general picture of this one. So first of all, you just like make a scale for the x direction. It will have to cover from -5 to -2. Okay, -5, -4, -3, -2. So just a couple more left and right. Add another one more point. Okay. Oops, where did it go? All right. And then put pieces together. It has the slope 0 at -4 and -3. The lowest one at x equals -5. So the lowest, and the highest at -2, highest. Okay, lowest, highest. So the graph will not be below or above the point -5 and -2. Alright, so maximum, absolute done. And for the local at -3, local minimum, that means this is in the interior point minimum is not overall minimum. The overall minimum already told you to be at -5. So at -3, local minimum and the slope is 0. Just make it like slope 0. Local minimum, so make a dip here as a turn, as a smooth turn. Okay, does it make sense? So the derivative is 0. The f prime at -3 equals 0, and also the local minimum at -3. And then what else do we know? We know that the slope at -4 is also 0. Okay, -4 could be local max, local min. That's, we don't know for sure. That's the options, more options for you to sketch the graph. So let's um do something. Let's just follow the information here. If the slope at -4 also 0, but it doesn't say either the negative at -4 is maximum or minimum. We can make more option by, you can make it as the local max if you want, or you can make the graph like not the local max. It doesn't matter as long as you satisfy this information. The slope at that point is 0. Okay, slope at that point is 0. And not the absolute max, because absolute max given at x equals -2, not absolute min, because absolute min happens at x equals -5. And then finish the graph. So this is one of the options. Okay, so this is one of the options by using information provided to sketch the graph. Continuous, the graph is smooth. from -5 to -2, the closed interval, and satisfy the derivative 0. Local mean appears here. Absolute max, absolute mean. Yep, we hit all information provided. Okay. So from this information, we can say x equals -4 and x equals -3. They are critical point, and critical point. Only one of them from our graph that we show that is a local mean. So when you get the critical point, it doesn't mean both of them or all of them gonna give you local max, local min. So you have to check further or whatever that provided for the graph.